We move on to the third and final part of this first topic of introduction to the studies of dynamism of coastal spaces using remote sensing.
In this third part,
we focus our attention on how the use of remote sensing can be applied to characterize the dynamics of coastal spaces. And as we saw in the previous video, the shoreline is a very useful key indicator that can also be easily deduced. Multispectral satellite imagery, especially if infrared bands of the electromagnetic spectrum are recorded. In fact, the medium-resolution satellite images obtained within the optical range of the electromagnetic spectrum they are becoming a new and especially useful documentary source. We are referring to the images captured by satellites North Americans of Landsat series and the European satellite Sentinel-2. And both Landsat and Sentinel-2 images record the same bands of the electromagnetic spectrum. They cover practically the whole Earth, and do so systematically. In addition to in recent decades, his archives have remained open to be used for free by technicians and scientists from anywhere in the world. In fact, both series of images have two extraordinary advantages to make evolutionary studies of the coasts. The high frequency with which they register the same place at present is once every 5 days on average. And its longevity, i.e., they have been systematically recorded since the middle of the 80s of the last century, which brings a perspective temporary of about 40 years. The most important problem they have is their spatial resolution, 30 for Landsat images and 20 or 10 for the Sentinel-2. What can be too gross to characterize many of the beach changes? And that is why in recent years they have been developing multiple proposals to automatically extract shorelines of these satellite images. Some of these solutions detect the pixels that define the land-water edge, and therefore the coast is defined as a pixel. There are, however, other solutions that try to locate within of the pixel itself that is defined as coast. What is the position most likely from that shore? These are the sub-pixel solutions. With these algorithms have created software packages with which you can extract efficiently hundreds or even thousands of shoreline positions for the same place. With the successive shorelines or SDS, i.e., satellite-derived shorelines, morphological changes can be detected to the same place, associated with short-term processes such as those associated with a coastal storm or those that are given for a human work. This is the case shown on this slide, where they appear overlapping successive SDS records during the year 1990. Therefore, more than 30 years ago, when it became an artificial contribution of sands in this beach of Valencia. Successive SDS allow us to recognize how the new sand spill caused the widening of the beach in the spring of 1990. However, a few months later, at the beginning of the summer, the beach had already been regularized and the new sand had migrated to immediate areas, leaving a morphology of the beach similar to the situation before the work. It is extremely interesting to note that this analysis has done now on something that happened in 1990, using images captured then by Landsat 5 satellite. We can then monitor old performances and know what response had the coastal system. But have tens or hundreds of SDS of large coastal segments is certainly a great opportunity that, at the same time, forces design solutions for how to analyze that information. One of the proposed solutions is the creation of the space-time models of changes of width of the beach. These models are created by systematically measuring the width of the beach on small stretches, for example of every 50 m, on the successive available SDS and calculate the difference of width with respect to a given date. The information about changing the width of the beach in each place and date is organized in a Cartesian axis in which x is time and the y is the space and are represented by a gradation of colors. the magnitude of the changes in space and in the time. In this example, it shows how it has changed this coastal segment of just over 8 kilometers of beach between November of 2020 and February of 2023.
In that period,
a series of breakwaters were built in the northern part, what caused a clear advance of the shore in this sector, but an accelerated erosion just to the south. These analytical tools can be very efficient for monitor sets of changes on the beaches, and with this we end this first topic. Thank you very much for your attention.